A flute is 63.6 centimeters from the hole the player blows across and the end of the flute. What are the frequencies of the lowest note and the next higher harmonic of the flute? The speed of sound in warm air is 350 meters per second, and we have a hint that we need to model the flute as a pipe that is open at both ends. So we'll draw a picture first, and we'll say, okay, this is our pipe. It's open at both ends. So if it's open at both ends, then we need a peak or a trough at each end. So if we think about that, that means we're going to have the wave is going to look something like this. That's going to be the first harmonic. And so if we say that this is going to be L, and that's equal to 63.6 centimeters. And we know that V is equal to 350 meters per second. So this is what's given. And we're going to find, we need the frequency F1 and F2. Okay, so if we look here at our wave, we see that our lambda is equal to, well, let's instead say that L is equal to lambda over 2, right? It's not a full wavelength. We only have half a wavelength. So that's lambda over 2, and our velocity, v, is equal to f lambda. And so we see here that lambda is equal to 2L. So you can plug that in. So v is equal to f times 2L. And so therefore, and we'll call this one F1. So F1. So F1 is equal to V over 2L. And if we plug in our numbers, we're going to have 350 meters per second over 2 times, and I want to put this in meters, so 0.636. Right, so F1 then is going to equal 275 hertz. Okay, so what about the next one? So that's the frequency of the lowest note. And now if we want to figure out the next one, let's draw another picture. The same, hopefully I make that the same length L. Okay, and so now for the first one, right here, let's see, for this one up here, right, we see that our wave for that L, the smallest, I guess the smallest wave that we can have is lambda over 2. And what's next, right? That's what we have to figure out. So in this one, we're going to say, okay, well, we need a peak or a trough. And so we already had a trough, so we're going to have a peak this time. So we're going to go like that. And so that's a full wavelength. So here we're going to say L is equal to lambda. So this is going to be our lambda 2. And so we're going to use the same equation again. So V is equal to F2 lambda 2. And so that's going to equal F2 times L. So F2 is equal to V over L. And we know that V over L is equal to 2 times F1. Right? So if we look at this equation right up here, right, we see that F is equal to V over 2L. So F2 is going to be equal to 2 times V over L. And that will give me just plain V over L. So that's why I need to multiply by 2 here. that out of the way. Okay, so F2 then is going to equal 2 times 275 hertz. And so F2 is equal to 550 hertz. So those are the frequencies.